Hello. 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 Good morning. Hello, Melanie. Good morning, Vincent. Thank you. Thank you. And I'm taking that to mean you can hear me. That's great. Good morning, Vicky. Awesome. Good morning. Here we go. Jean. Good morning. Good morning, Vanita. We're rocking, and I'm assuming you can hear me. Good morning, Gabriel. This all means you can hear me, right? No, it's amazing how the video percentages are going down already. Not surprising. Okay, good morning, guys. But you can hear me, yes? Yeah. There's Gabriel. Oh, he's doing it. He's taking one for the team. Thank you, Gabriel. He didn't even, guys. That's a new portal. Taking one for the team. All right, but thank you. But you can hear me, yes? That means you. Yeah, okay. All right. Awesome. Awesome. Good morning, everybody. Who else did I not say? Okay, so let's just get rolling. We are gonna get rolling. Okay, I think now again, you can stop me good morning, Miriam. All right, excellent. So I think I'm going straight to homework 2 now. Again, stop if there's any unresolved business from Monday or anything I'm forgetting, stop me right now or put it in the chat. There may be something I'm forgetting, or anything that's still confusing. Let me know. In fact, let's pause for a second. If there's any questions at all from yesterday or from life, I'm happy to answer them right now.
Quick question. Can I make my own like legend? It doesn't have to be specific to what you want. Like, for example, if I choose a letter W, which represents, let's just say, walking, can I do so?
Oh, that's a
Or
great
does it
question.
have to be specific to what you want?
No, I think I understand that. That's a great question. I think I understand. In general, it's great to be able to you can make up your own things, especially like you say, if it's a legend, like if you're saying W is going to stand for walking, here you go, and you make it clear. Yes, you can always do that, and it's a really good idea. The only thing I would say is like from as we proceed, if we start having standard things that we're always using, like if we're always using in the class, like V bar stands for average velocity, I would recommend that you also use that. Like the things that we're already using, we kind of want to all use together because it's like a standard language. But for sure, in any problem, if there's a particular detail of that problem, right, like a man is walking or something like that, and you want to say for this problem to make it clear, I'm using W to stand for walking. Absolutely, that's a great yes, yes. Does that make okay? Cool. Okay, awesome. Great question. Okay, so is that and if that answers it, you get more points, as we know. Blah blah blah. But okay, does that okay? All right. So and again, keep the questions coming. Just because I start does not mean, but you know how it goes. Once I get rolling, I'm just going to roll. But anytime you want to stop me, it's good for everybody. So, but where I'm going to go now is to homework 2. I'm going to, I'm just going to write down quickly. I'm going to try. Oh, in fact, I have to get something in a second. I'm going to just try to quickly write down what I think the answers are to the first couple of warm-up exercises, just so that you can see if you're on the same page. Because again, as you're seeing more and more, when you get back these sheets, I don't like mark every single number or anything like that. So right now, and you can get all the full credit even if you didn't get all the right answers or vice versa. So right now, just quickly on the warm-up exercises, I'm just going to write the answers down. And if you're cool with them, then we'll move on. But if you have any questions, you'll ask them. After you check your answers, then I'm going to talk in more detail about what I think are the more involved, thought-provoking problems, the last two, Hill Figure and Grandma Grimm. Like those I'm going to talk about at length. But first, let me just scroll out the answers to the first couple. So bear with me for a second. Oh, let me just, sorry, I'm just adjusting the screen. I'm getting, sorry. Right. Okay. And also, okay. Oh, someone's here. Pardon me for 1 second. Okay, someone's here. Okay. Um, and sorry, Melanie, wait, do you have for some reason your screen, I don't know, wait, oh, maybe because I'm not talking? Wait, for some reason your screen, this is not to Melanie, do you have a question or for some reason
No, I don't have a question.
okay, I didn't think so, but for some reason your square, hold on, I'm just adjusting this for some reason your square, just maybe because you were the last person to talk. Hold on 1 second. No, no, no. Okay, okay, okay. Well, I'm just adjusting something on the Zoom or really on the recording to tell you the truth. But while I'm doing this, just so what you could see right now for anybody who just joined or whatever, these are just the answers for the warm-up exercises, just so that you can check to make sure you're okay, because they're not meant to be. And you could get it's there's no shame in asking any questions about them. But like notice this is not a process. That's not the 5 step. Like your homework would to get full credit have to look more elaborate than that. But those are just my final answers for you to check. I'm just still trying to fix something. Well, something's funny in the Zoom. I apologize. It's not a big deal, but so I'm going to go on a second and talk about what I think are the more thought-provoking problems of the last two. But there's one other but before I do that, I guess one other like a little observation. I think it came up in the other section, but notice that I'm still using English even for my final answers are expressed as full statements. Like the average speed is this, right? Like there's just like subject and a predicate or a noun and a verb, so to speak. All final conclusions in math or physics are still complete thoughts. In English, we call complete thoughts complete sentences, right? I'm not trying to be weird, but like a complete sentence of English captures a complete thought, i.e., a conclusion that might be scientific or even mathematical. Math and science follow the same idea that we express ourselves incomplete thoughts. Everything in the end in math or science has to have a subject and a predicate or a noun and a verb, if you like. It's just that. It's just that in math, the verb is always equals. Like, no joke. I don't know if you've totally ever thought about that before, but like everything in math is a thought. It's just that the verb is equal, like this thought is something is equal to something else, right? So okay, so so all of these are still complete thoughts at the end, but notice that they're a mixture of English, like they don't look like equations yet. Those do not look like equations. And the simple, now that we even have an equation, you might wonder why is the Averbound like not using the equation? only because technically these questions were still asking about average speed. So I view average speed as like the English concept that we built average velocity from. Once we're now that whenever I'm thinking in terms of average velocity or and beyond, then I express it with the V bar, and I do it in equations. If I'm still thinking in the more intuitive, non-directional scalar idea of speed, I express it in English. Why am I making a big deal about that? Because what I'm here to, because we're going to get obviously all the rest of this class today and the rest of the class, like everything I'm going to do is going to look more like math and manipulation of equations and stuff. As the math gets thicker and thicker, that will be more fun and more exciting or more clear to some of you. It'll be more annoying and confusing to some others of you. Fine. I'm here to stress the reason we spent a whole week doing these without equations is I really want you all to see that equations are just symbolic, like abbreviations of normal complete thoughts in our native language. I mean, in some of us, English is not even our first language, whatever the language is. I want you to see that equations and math is not just some weird thing over here that's like different. It's not. It's just a shorter way to express thoughts that are already in our head. Ultimately, perhaps a more efficient way to express thoughts that are in our head. So we're transitioning here from this like equanglish, like this like equations built around English words that then will look more symbolic as where I'm thinking in terms of average velocity and stuff. But please see that as a transition. The equations are not. This is why I never use the word formula. Bottom line, equations are not just like magic formulas that we just invented or pulled out of a hat and now you memorize. Equations are just abbreviated expressions for natural thoughts that we're all having and all actually hopefully make sense. Okay, so I'm going to start doing things in more equations. Please try to think of them as just shorthand for the thoughts that we're discussing in class. Okay, and so in the next two problems that I'm now going to analyze, at the end of the day, I think the problem asks for average speed, I think, or at least the first one. Well, okay, so I'm going to do Hill figure now, right? I'm going to do Hill figure. This is still homework. Two, I guess it was problem three. I think it's problem three. Hill, sorry. Just getting used to new. Problem two, yeah, problem two. Um, Hill figure. And at the end of the day, for this problem, we're asked, what's for an average speed? So, in other words, at the end of the day, we're asked for an average speed for this problem. So, at the end of the day, I'm not being asked for something that has a negative sign or a positive sign. I'm not being asked to be concerned with what's the direction of my final answer. So, my final answer, I'm just going to express as a number, as an average speed. But I'm going to do my thought process, I'm going to think it through mathematically. Um, and so I'm going to be talking about average velocity and stuff. It's just that I don't think that the direction of the average velocity is going to uh make a big difference in this problem. Okay, anyway, I'm over talking. I'm going to do it now. So, okay, I'm just going back and forth. So I'm going to solve the Hill figure, but I should have stopped. Are there any questions at all? Sorry, I already turned the page. Wait, are there any questions at all or any concerns about any of these answers? Like, are we cool with, honestly, I'm just going to pause for a second. Thank you, Gabriel. All right, Gabriel, taking again for the team. All right, I'm going with Gabriel's. Okay, cool. Okay, so I'm going to go on. Okay, so Hill figure. Um, All right. Oh, and Annie. Okay. And hello, Annie. Okay. So he'll figure. So step one. All right, so to be clear, sorry, there's ah, okay. Sorry. So I'm trying to say in very illegible handwriting, I'm trying to say, here's my diagram. Uh, it's not a very good diagram, but the car goes up at an average speed of 40 miles per hour. Then the car comes down at an unknown speed. Oh no, I'm sorry. I'm sorry. That's not, bear with me for a second. I'm confusing two problems at the same time. I don't know. Okay. Okay. Sorry. So we're given that on the way up, it's 40 miles per hour. Then on the way down, on average, it's 60 miles an hour. And we're being asked, okay, if that's the case, if he goes on average 40 miles per hour on the way up and 60 miles per hour on the way down, what's the average speed for the whole round trip? Right. So that's the deal. That's step one and step two. Notice again, because I want to start thinking in terms of equations, I'm going to start using the V bar, right? And I'm going to start doing math. But V bar, strictly speaking, stands for average velocity, which strictly speaking takes into account direction, right? So honestly, strictly speaking, I think if I didn't know where this problem was going, or I was thinking about this for the very first time, it might be totally relevant. And in the long term in physics, it is totally relevant and meaningful that I might decide that the up direction is called positive and the down direction is called negative. And strictly speaking, then the average velocity on the way up is positive 40. The average velocity on the way down is negative 60, right? And I would want to take that into account. And that is true. But this problem happens still to be at the early end of the semester. So it's asking not for average velocity for the whole trip. It's asking for average speed for the whole trip. So I'm making a decision right now that I want to think mathematically, but I want to think precisely and carefully. So I'm saying the absolute value, like the magnitude of the velocity on the way up is 40, and the magnitude of the velocity on the way down is 60, right? In other words, I'm translating the word speed into the mathematical notation of absolute value of velocity. That's really what speed is, right? Speed is the magnitude of the velocity vector, so to speak. Now, again, I'm being overly technical. I'm not saying you had to do it this way, but I'm just so that you can understand why I'm choosing the notation I am. That's how I'm doing it. Okay, so I'm solving for the round trip. For the round trip magnitude of absolute velocity, i.e. the round trip average speed. That's what I'm solving for according to step two. So step three, now here's where it gets interesting for some of us. Step three, GDP, I have to write down something that is true universally even before I do this problem, right? I got to write down a truth, a definition or a principle or a law. Now, there's only one that I have in this class so far. I'm going to write it down. The only truth that I know that's relevant to velocities or speeds or anything else is I know that average velocity is defined to be displacement over time. So I write it down on this pad that is giving me troubles. So I write it down. Now, I that's not hard. Like that's the only thing we know. So that's what I write down. That in itself is not hard. However, already, like having looked at a lot of the homeworks, and a lot of the homeworks are great. Well, all the homeworks are great. A lot of homeworks totally nailed this one, which I'm really pleased. And I'll even admit, like 5 years ago, 10 years ago, 15 years ago, no one used to get this problem right off the first bat. Now, a lot of people in this class have it. It's either because we're all getting smarter and cooler and more hip to physics, which is great, or maybe it's because people looked at past videos, which is great. I mean, really, either way, it sort of pleases me. But some of us still did not get this problem right. No shame. But let me say again, like I might have said in class yesterday, I don't think the answer is going to be 50. The answer to this problem is not going to be 50. Uh, the reason I don't, the reason to think that it would be 50, the reason to think that the answer to this problem would be 50 is if you in your mind thought of average speed as the average of speeds, which is not crazy. It's not unreasonable. It's not criminal, but it is wrong. Like average speed, like if you got 50, I'm not sitting here shaming you, but I want to be very clear. Like if you got 50, it's totally human. It's the common misconception to write 50 for this problem. But if you wrote 50, that means either you skipped step 3 GDP, if you really think about it. It means either you skip this, what I just wrote down, or somehow you made up information that's not true and put it in here or something. Or if you didn't skip step 3, more likely what you did is somehow mentally or on paper, you invented a GDP for step 3 and sort of somehow wrote down something like the average of speed. The average speed equals the average of the speeds, 40 plus 60 divided by 2 equals 50 or something. Now that's like all mathematically correct. I'm not saying that is how you average two numbers. But what I'm really trying to emphasize right here, like this is I'm trying to say, wait, if we follow the 5-step method for physics and we actually force ourselves to, before doing calculations, before we just dive into calculations, if we stop and write down what's actually true, what I just wrote here is actually true. And this has no way of producing the number 50. The only way to produce the number 50 is to write down something that maybe seems vaguely like true in other cases in other classes, but isn't actually a truth of physics. Okay, I'm beating a dead horse. But I want to get this from the other angle now. Why some of you wouldn't write this down? Well, okay, here's what I'm really trying to say to everybody. Okay, at the risk of being I'm about to beat the dead horse. I'll just say this quickly because I just wrote it down. As things get harder and harder, now again, I'm over speaking at things when they're not that hard, but this problem is the first problem we have where people can get it wrong, really. So as things get harder and harder in physics or in science, As we get more and more into exams where you're looking at the exam and it says a bunch of stuff and like we say, oh my God, I don't even know. I have no idea how to do this. I don't even know what this question is asking me. Oh my God, what does the professor even want? Blah, 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 blah. Or it's real research and you're like, I have no idea what how to design the experiment, blah, 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 blah. The tendency that people have, really good people, really experienced smart science students, really good experienced science scholars, a tendency that people have when they panic, when they think something's getting harder than they want, what people tend to do is first try to think of things that are relevant and then make them true. Like you don't consciously do this, but people, especially on an exam, if you don't know exactly what's going on and you're starting to think it's hard, what people tend to do is like, what does the professor want? What is this question like? What is the question like looking for in the end? Let me write that down. And then let me do a bunch of algebra and stuff to try to make what I wrote down get me to a seemingly correct answer. What I'm here to tell you is no, that the secret to working your way out of a panic or the secret to knowing what to do when you don't think you know what to do, when it is, don't try to start with things that are relevant and then make them true. Start with things that are true and then make them relevant. So even in a case like this, and I'm drumming this in because it's a habit that becomes more and more important as things are harder, but it's harder to do when things are harder unless you practiced it. So right here, the only thing to write down for step 3 DDP is V bar equals X minus X naught over T. But the reason that many of us wouldn't write it down, check it, yo, check it. The reason that many of us would skip this step in this problem, even if like we ultimately got it right, the reason we would skip this step is we would look at it and go, that can't be what's expected right now because I don't know anything in that equation. Like the thing that makes this problem hard is even if you are smart enough or dutiful enough to write this down, you then, or to think about it, you then look at it and go, hold on. It says displacement over time. I don't freaking know the displacement. I don't know how big the hill is on the way up. I don't know how big the hill is on the way down. Therefore, I totally don't know how much time it took me to go up, and I don't know how much time it took me to go down. So for a lot of us, I'm not saying all of you, and in fact, it may even be a minority in this class, which I'm proud. But in general, a lot of us wouldn't even write that down because our brain would be one step ahead of us going, that's not going to do any good. That's not going to do it. You don't even have any of the information. And I'm here to say that's a habit we want to break, like as early as possible. If something is true, we write it down. And if nothing else, we're going to get points for it on the exam from Yaverbaum just because it's true and it's a step. But now we write it down really so we can trust ourselves and trust the process and start looking at it and going, okay, so I'm going to the next page. I'm going to go. So step 4. So I've written this down. I don't know what is wrong with this. Okay, so I've written it down. Oh, and here comes a thing like Melanie. Before I go any further, like I'm looking at it, I'm like, I don't know anything. So I'm like a little bit panicking. I don't know any of this information. Doesn't mean I've done something wrong. It means I got to find it out. So first I'm going to do like what Melanie sort of suggested 20 minutes ago. I'm going to say, okay, X naught is supposed to be the initial position where we started. Now, this is not, I wasn't told that, right? But since I wasn't told it and I wasn't given a number line or anything like that, there's no reason, and we're going to get into this more in the next, there's no reason I can't like follow Melanie's lead and make my own decision, my own coordinate system, and say, you know what, wherever he started at the bottom of the hill, since no one put a number line there for me, I could put a number line there myself, and I could say, I'll let wherever he started at the bottom of the hill, let me call that 0. Right. And that's what everybody does in their mind anyway. If the hill is 30 miles long, then they say that the displacement of the hill to the top is 30 miles because it started at 0. So first of all, I'm just going to say, and can I do that? Yes. And we'll talk more about that with the next homework, but I'm choosing my perspective. I'm choosing to impose a coordinate system on this problem and say that the initial position is going to be called 0 from here on in. So that'll save me some unnecessary math. But now X and T, that is definitely unknown. And also, I guess I'm following Melanie's thing here. I'm tacitly letting, and I should have probably put this. I'm not going to go back now, but I should put these in my diagram. If I'm calling X up, if X up means the distance on the way up, that should be a label in my diagram. That's really the purpose of the diagram. And X down should be a label in the diagram. I'm not going to go back and change that right now, but um, and those are definitively unknown. Again, I know I'm emphasizing what's hard about this problem is that a lot seems to be unknown, but it doesn't mean I can't. It means I have to focus on them. It doesn't mean skip around them or avoid them. It means focus on them. So X up and X down are unknown. Wait, I'm just looking at the, okay. Um, what do I do with them? Well, just that. If they are the things that are the issue of the problem, and if they are things that are unknown, then I'm going to start expressing knowledge directly at them. In other words, I'm going to say this. Sorry. Oh, yeah. Oh, sorry. I don't know what's going on with this tablet, but so for what I'm trying to say, I know my handwriting is worse than ever. I'm trying to say, I'm going to focus on the up trip right now. I'm going to do the same thing I did yesterday. If I know that V bar equals X over T, I shouldn't be scared of the fact that I don't know X or T. I just know that V bar equals X over T by definition. Therefore, I rearrange. And I did my first step skipping thing right now. I just skipped a step on the paper. Like, what did I do? I cross multiply both sides. I multiply both sides by T, and then I divided both sides by V bar. So I'm saying that just like yesterday, we didn't make a new equation. We didn't make a new definition, but we just believed that if V bar equals X over T, like yesterday, we believed that Monday, if average velocity equals displacement over time, then displacement equals average velocity times time. Well, similarly, time must equal displacement over average velocity, right? I'm just rearranging in my head. I'm not memorizing a new equation. I'm not, for all time, I'm not making a new triple equal sign. I'm just saying time up, in this case, the time up the hill must equal the displacement up the hill divided by the average velocity up the hill, right? So the time up the hill has to equal the displacement up the hill over 40. Now, again, just note, by the way, there's a million ways to do this problem. This is just one way, but I think it's one way that's clear. Notice I still don't know the displacement up the hill, but that's okay. That's the point of algebra, is that like letters can stand for numbers. I mean, again, kind of like what Melanie was saying before. So the time up, and by the way, what I'm doing right now, I mean, I'll stop talking so much. I'll get to the end in a minute. But I want you to see too, even if your paper looks nothing like what my paper looks like, notice I'm doing stuff to get to the end. I don't know exactly. I mean, I do, but I'm doing stuff that is true. and hoping that it'll progress me to a final conclusion, I don't necessarily see the light at the end of the tunnel before I start walking into the tunnel. I just have the confidence to believe in the path. So, so I'm now going to keep going and say, similarly, the time down must equal the displacement down over 40 miles per hour. Yes, like true statement, right? Now, why do I care? Why do I care? Well, because then I can start putting these things together. Like, what else do I know about the time up and the time down? Or what else? What do I know about the distance up and the distance down? I think I know nothing, but that's not quite true. I don't know what the distance up is, and I don't know what the distance down is, but I sure do know that they're the same, right? I sure do know. I mean, it's one hill. X up must equal X down. So I can stop calling that. That's not true of the times, but it is true of the distances. So I can, in fact, start making this a little easier on myself and stop calling them X up and X down and just call each of them X because it's the same, right? So I can say for the entire round trip, the absolute value of the average velocity must equal, by definition, it must equal the absolute value of X plus X over T up plus T down, right? I'm saying for this entire round, like if average velocity equals displacement over time, then for the entire thing, the average velocity has to equal the entire displacement plus the entire time, right? Right? And the entire time is the time up plus the time down. And the entire distance is the distance up plus the distance down, except that those are the same. So this is starting to look a lot simpler to me. In other words, it's starting to look like this. Tx over T up plus, 2x over T up plus T down. Right? And so I'm going to the next page. I'm just looking if there's anything in the chat. No. And I'm substituting in T up, we said was X over 60. And we said T down, 40. And we said T down was X over 60, right? Originally we said X up over 40 and X down over 60, but we just realized X up and X down are the same thing. So now we're starting to get something like simpler and simpler. The absolute value of the average velocity for the whole thing is 2x over x over 40 plus x over 60. And that's kind of a messy fraction. Like a math teacher or a math professor wouldn't necessarily like it, but it's not really that bad because I think you can see, like I can factor out an x from the bottom. Sorry, I can factor out an x from the bottom, and I can factor out an x from the top. And again, for all of it, like some of you do this in your head, I know, and some of you are still uncomfortable with it, I know. So I'm just writing it out, like whoever you are. But but by the way, if you're a person who can do this all in your head, that's great. But still, remember, someone asked me this the other day. When you're writing this out for homework or exams, anytime a step occurs to your mind and you go, is this step really worth writing down? If you're even asking that question, if you even see it as a step in your mind, write it down. bottom line. So here we are. So now, this is actually not that bad of a, I mean, there's a million ways to do this frac, but well, the key point, the huge point is, even before I get intimidated by these fractions, if I factor an x out the top and I factor an x out of the bottom, then x over x equals 1, right? In other words, the x's cancel out. However you want to say it or however you want to see it. The huge point here is I don't have an answer yet, but the x's just canceled out. That's huge, because the X was actually my psychological problem from the start of this physical problem. Like, my problem at the beginning is I don't know how big this hill is. I don't know how far it is up. I don't know how far it is down. Therefore, I don't know how much time it took to go up. Therefore, I don't know how much time it took. But the one thing I didn't know was the size of the hill. It all came down to, if I just knew the size of the hill, I would think that I'd be okay. And what this step is telling me is, guess what, yo, the size of the hill doesn't even matter. You're going to get an answer that doesn't even depend on the size of the hill. The one thing that was annoying the whole time is the one thing that actually doesn't matter. And in fact, that's a huge physics insight right now. I know we're not done, but that the fact that the x's are canceling out right now is a huge physics insight in itself. Because the truth of the matter is, if you really back up and look at the question, there's no way a question like that even makes sense. Like, if the question is saying, here's some hill, it goes up, it goes down, what's the average speed? If the question didn't even specify the size of the hill, and yet it's a coherent question, like if it's not a messed up question, if the question has an answer, but the hill wasn't specified in the first place, that actually has to mean right from the get-go that the answer must be independent of the hill size. I mean, I don't know how you want to put that in your notes, but like literally on exams or in research, that is the deal. If somehow there's a scenario where you're presented with a bunch of information and there's a conclusion to arrive at, like if certain key information at the beginning is not part of the presentation, that means the conclusion is independent of that information. That's kind of staggering. So we'll go back to that again and we get an answer. But I'm saying right now, I don't even care what size the hill is. I'm going to get an answer. Okay, so how can I get an answer? I have to add two fractions, right? How do you add fractions? You have to get a common, I mean, do whatever you want. I like to get a common denominator. So I'm going to say, sorry. But this thing right here, I don't know. To some of you, it looks hard. Some of you, it looks easy. But 2 over 1/40th plus 1/60th really is I'm going to simplify it now. But really, that's the meat of this whole problem. Well, if you stand back and look at it, what we're really saying is the average speed of this whole thing of going up and going down is really, it's not the average of 40 and 60. It's really, well, it's really this. I guess I can't say it any better than that. It's really the relationship of the fractions 1/40th and 1/60th, i.e., in other words, this. Right? So it's 2 over 5 120th, right? I just got like a lowest common denominator. And I mean, if you want help with that outside of class, I'm happy to do it. But 40 goes into 123 times, 60 goes into 122 times. So I did it like that. Then I add the fractions together, right? Because you can always add fractions when they have a common denominator. So I got 5 120th. So now I have 2 over 5 120th. So how do you divide fractions? You multiply by their reciprocal, if you know what I'm saying. So I'm going to multiply 2 by 120 over, in other words, this. So I get 240. Now here's the key. This all just looks like weird. Like what? Where's 240 over 5? Well, let me tell you, and I'm looking at the chat. Okay. 240 over 5. So that's all my work for this. This is one way of doing it. I don't expect that anybody's homework looked identical to this. But if you look at your own homework, especially if you got it right, if you look at your homework, especially if you got it right. Sorry, someone to you. Um, I guarantee you somewhere in your homework, if you got it right, if you got it right, somewhere you're going to find something like related to 240 over 5. Or these numbers somewhere are in your homework, even if you, and I'll show you why in a second. But what that means in the end for step 5 in the end, okay, I'm looking at the chat. So, okay, I see something in the chat that's good. I'm going to answer that in 1 second. First of all, I think the answer for this, the answer is the average speed for the entire round trip is 48 miles per hour. I believe that's the one and only correct answer. I also believe there's other ways you could have gotten to this as long as you did the 5-step method. And as long as your step 3 was average velocity equals displacement over time, or average speed equals distance over time, as long as you did a 5-step method and your step 3 was that, and as long as nowhere in your thing you seem to be implying that you could get an average speed by averaging speeds, then you would get full credit for this problem. Oh, and then certainly if you got that answer. I mean, even if you didn't like do it the way I did, there's other ways you could have done it. But you can't just average 50. You can't just average 40 and 60 and get 50. Like, I'm going to talk more about that in a second, but there's something in the chat. Hold on. Oh, okay. Oh, okay. Wait, and I'm looking at the time too. Okay, couple of good things in the direct chat. So first of all, important question in the direct chat. If you didn't get all the points for whatever reason in the homework, but if you didn't get all the points, and even if my feedback wasn't totally clear or wasn't as much feedback as you'd like or something, but if you didn't get all the points and now you see something that you actually did wrong, like, and you want to correct it for the rest of the points, absolutely, you still can and should do that. And so the question is, what's the deadline for that? There are still no deadlines for resubmissions. Like you could submit once, you could submit again, you could keep submitting until you get all the points until I say otherwise. You can even resubmit after we've moved on to the next homework. I just don't recommend that. So my soft recommendation is try to do as many resubmissions as you want or get all your points you want, and but then move on to the next homework. When we move on to the next homework, don't get into a loop. That's a recommendation. But until I tell you otherwise, I will accept resubmissions and re-uploads and corrections to get all the points. Like, I'll accept an infinite number of drafts and an infinite number of days until I say otherwise. Again, someone's asking this in direct chat. I think it's a very good question. Just one constraint on that is, please, every time you do a revision, please do upload a new draft. A new document. Leave all the documents there still. Do a new document. So even if it turns out you're just correcting one line or something, and you're just doing it for 2 more points, fine. But don't expect me to find that correction in your old piece of paper. Like, you do have to recut somehow. You have to give me always your most recent draft of anything. Always is like the most complete and best. And so I see all the others to see all the progress. And so if I want to, I can flip back and forth and compare. But I should only have to look always at one document at a time to assess what's going on. I hope that's clear. But yes, there's no deadline. Oh, great. Okay. So good. So yes, for still all of you, you still can get all the points on anything still. Again, as we proceed, I say all the points. There's still a thing where, like, the first draft of a homework, the first draft does have to be submitted when the homework is due. Right. So that's and so you'll get a bunch of points right then. And sometimes you might have even seen today, no, maybe not this section. Sometimes you're going to get to the point where you're going to end in a homework right on time. And right away, you're going to see a bunch of points on it. That's like almost all the points. And you won't even see feedback. Like, when I start getting behind, sometimes you're going to get a whole bunch of points on a first draft. That just means you're totally you're in time. Like that's my acknowledgement. Like you're still in a position to get all the rest of the points, but I didn't even give feedback yet. Pay attention to what's going on in class. You'll probably figure out what more you can do, and then just do it and you'll get the rest of the points. And, or if by the end of class, like sometimes this will happen, if you submitted a whole thing and you get a whole bunch of points and we go over in class and you're still like, I think it's perfect actually. And you hadn't even gotten feedback yet, just submit it again. Just literally just be like, yeah, I think he just didn't even, I mean, okay, he was rewarding me for being on time. Now I'm pretty sure my answers are dead on right and there's nothing to do. Just take the same draft and submit it again. And then I'll look at it and be like, oh yeah, no, she's right or he's right or whatever. I hope that's what I'm saying is the flip is that more and more as we proceed, if you're worried about deadlines, if any of you are worried about deadlines, the deadline is you have to put in a first draft when it's due in order for you to have all the rest of the points available to you. Like I won't give all the rest of the points to anybody that didn't even make it in the first. You follow what I'm saying? So that's why, like, okay, hopefully that's clear. That's why sometimes, as long as you get it in, you'll immediately see a whole bunch of points, even if you don't see feedback. And that's saying, yeah, I'm acknowledging you're on time, you're good with me. We're off and running. Now we'll just revise as we need, or we'll just resubmit as we need. Okay, I think that's clear. If it's not, let me know. But I'm looking. Okay, you got it. Okay, so now, okay. Cup 1142. I'm going to proceed momentarily to the very last problem. I'll tell you in advance that the last problem, and this happened with some of you on the homework, the last problem is the same exact, all the same concepts as this. It's one touch harder. I'll address that in a minute. But if you really get the concepts of this one, then the next one follows the same way. In other words, both of these problems are here to really test that you really see. Okay. And same with velocity. I should have expressed this final answer in English. Hold on. The takeaway for this problem and the next one is terms of triple equal signs. The definition of average speed is not average of speeds. The definition of average speed is distance over time. Does that mean that average speed could never be equal to the average speeds? No, it doesn't mean that. We're going to get to that in a second. This is the difference between triple equal signs and double equal signs. There are scenarios, actually, that we're soon going to get to, where sometimes average speed does turn out to be the average of speeds, but that's not by definition true. The thing about definitions, why step 3 is often a definition or a law, is definitions, when they're true at all, they're always true. You can rely on them. You cannot rely on the idea that average speed is the average of the speeds. You can rely on the idea that average speed is a distance over time. So that's takeaway number 1. Takeaway 1. Hold on. I'm just trying to fix the view on the screen again. Bear with me. Why? It's so weird. Well, it's not letting me. Okay. Takeaway 2. You might say, especially if you're still with me, if you're still paying attention, like I don't know, like Gabriel and Annie, for example. No, but if you're still with me and you're like a smart, critical thinker, like Gabriel and Annie definitely are, and Melanie definitely is, and everybody else definitely is, but just haven't heard from them yet. If you're a critical thinker, you might be thinking to yourself, well, first of all, you're probably thinking, can he just go on? Can he just freaking do the next problem? Okay, yes, I can. The next problem, the answer is infinity. Okay, I'll say that. The next problem works the same way, but it's a little bit harder because the actual answer is infinity, i.e., Little Red Riding Hood would have to go infinite speeds in order to accomplish the task of the next problem. That's a little bit tricky, but it's the case. If you got it right, then if you got it wrong, you're definitely going to want to listen to me right now to see where I'm going with this. If you got it right, then relax and she'll be like, fine, I got the next one right. So I guess I'll lose nothing by listening to whatever rant Yaverbaum is about to go on right now. Good decision. Thank you. Here's the rant I'm about to go on. You might say, well, for heaven's sake, if the big takeaway of today, is that average speed does not equal average of the speeds, it equals distance over time. Or if average velocity doesn't equal average of the velocities, it equals displacement over time. Then why, physicists, are you freaking using the word average? Like, really, guys? Like, really? And why, Yaverbaum, if you're making such a big point at the beginning, like equations are just abbreviated symbolic expressions of thoughts that actually make sense in our mind. Like, how are you supposed to believe that if now I'm going to sit here and tell you that you have to learn that average velocity doesn't mean average of the velocities? Like, what type of sense does that make? Right? Again, I'm not trying to confuse anybody. I'm not trying to tell you that I'm wrong. I'm trying to say if even in the back of your mind, you're like, this still seems like some kind of wacko-ness. Like what's the deal? Here's the deal. We are actually trying to make sense. We're trying to make very precise sense. The reason that average velocity is called average velocity is because, oh, yes, it is ultimately, it is an average. When you think about average, what an average is, okay. What an average really is, like the triple equal sign of average, what average really is the one value that best represents, that would be most accurate to work with when we're trying to capture a whole set of varying values. Like that's what average really means, right? There's different ways to get an average. There's different double equal signs. There's different ways to compute an average. But if you say that your average in a class is 85, what you're really, I don't care how you computed it. What you're really saying, if you say that your average in a class or your average exam score in a class is 85, what you're really saying is that even if you got a whole bunch of exams that had a whole bunch of different scores, if you had to pick one number that would lead to the same result, like if you had to pick one number that would be the most accurate to pretend that you had gotten that same number on each one of the exams, it would be 85, right? So now sometimes we do that by adding a couple of numbers together and dividing by 2 or something like that. But look at this situation here with the hill. So I'm dwelling on the hill for a second. I'm going to tell you now, I think 48 actually really makes sense. It really makes sense as the average speed of this whole situation, even though I didn't get it by adding 40 and 16 divided by 2. The reason 48 really is the best representation of how fast this car was going. In fact, I'm even going to wait, I'm going to pause. If anybody wants to answer, you don't have to. But if you're still with me, like basically what I'm asking is why is it actually make human logical sense that the average speed of this car is actually less than 50? Oh, yes, Annie. Yes, please. Thank you. Go.
Because it takes different times to go up versus down. When it takes longer, then the distribution of time is unequal. Like you can't assume that's just divided by two.
Yeah, totally. That was beautiful. And we should make up 50 more portals for that. Please find like at least 50 portals to put that in. I'm not kidding. No, that including like you used your voice, including you said something that could be right or wrong, happens to be totally right. Like, no, awesome. Also, I'm going to say it now my way. Yes. Like the point is really, this is the average. Like the point is, well, just what she said. You're going slow on the way up the hill. You're going fast on the way down the hill. So you're taking a lot more time to go up the hill than down the hill. So actually, if you really think of this as a whole bunch of test scores that you're taking, you took a bunch of tests, and you were getting 40, 40, 40, 40, 40. Then you took some tests and you got 60, 60, 60. But in effect, what Annie is telling us is you didn't get 60 on the same number of tests that you got 40 on. That's what she's saying. You actually took more tests that you got 40 than you did that you got 60. So your average is closer to 40 than it is to 60. I mean, I'm just repeating, like it's exactly what Annie just said. And again, and the key, what she said, unequal distribution. Yeah, unequal distribution with respect to time, because time is the independent variable here. Time is what we're averaging with respect to. So she's absolutely right that what's false about taking 40 and adding it to 16 divided by 2, it's not that we really don't believe in averages or something. It's that it's false to assume that it was like an equally distributed average like that. So it's really a weighted average. Now, and here's the kicker now, and I'm sure Annie understands this too. Like in my analogy of taking test scores and saying you actually took more tests that you got 40 than you did 60. Like if someone wants to ask, well, how many tests? Like, how do you know how many? Well, that's what this fraction is right here. What's really or this whole math is right here. What we're really saying is, you know what? It doesn't matter how long the hill is. What matters is that when you go 60 miles an hour, you're going 150% as fast as when you go 40 miles an hour, or you're going 3/2 as fast. Or put another way, 40 miles an hour is two-thirds as fast as 60 miles an hour. So you would spend 3/2, like the reciprocal of that, as much time going 40 miles an hour as you would going 60 miles an hour. Where am I getting, like, why did I just turn 2/3 to 3/2? Why am I saying inverse or reciprocal? Because the average velocity is displacement over time. Therefore, the time is inversely proportional to displacement. Again, this is all just an expansion of what Annie's saying. So in the end of the day, literally, like first conclusion, first insight is Annie's insight that you spend more time going 40 than 60. So the answer really should be closer to 40 than it is to 60. But then the next insight is how much more? This much more, 3/2 more, or 2/3 more. In other words, if you divide the whole thing, if you imagine the whole thing is like 5 exams that you took, the whole thing is like 5 exams that you took, you got a 60 on 3 out of 5 of those exams, 3 of those exams, 3 out of 5. And you got a 40 on 2 of the exams. Hence these 3s and the 2s and where's the 5 come from? Why do I have a 5 in the end? Because 5 is 3 plus 2. Like literally, there's 5 parts. 3 of those parts is going 40 miles an hour. 2 of those parts is going 60 miles an hour. So in the end of the day, the answer is 240 divided by 5. And the fact that the x's cancel out mean that if you see all this, and I'm not, believe me, you could see, I hope, I'm just getting excited. Like I'm not angry. I find this interesting that it all really does work out in the end. And of course, I'm also excited that at least one, I think many, but at least one person in the class seems to also see that. What's really exciting about the x's cancel out is what that really means. If you're sort of getting what I'm saying, if you back up, even if you didn't see all this before you began the problem, if when you begin the problem, if you just look and you're like, I think something tricky is going on here. I don't think it's going to be an even distribution. I think the answer, like you might, like I don't think he's going for 50. I see where he's going, but I don't know how to get it. But I think maybe it's going to be less than 50, but I don't know how much less than 50. If you see, or once you see that the x's cancel out, or that in the logic, it doesn't really matter how big the hill is, it just matters the ratio of the 2 speeds, then actually you could literally make up if you didn't understand all this or you don't like algebra, once you write down step 3, GDP, V bar equals X over T, and you're like, oh, but I don't know the size of the hill. If the minute you start to suspect that maybe the size of the hill doesn't matter, you could literally make up a size of the hill. You could call the hill 240 miles and then just do the math, not the algebra, just the computation. You could say, imagine the hill's 240 miles an hour. Then if he's going 60 miles an hour, then it would take, if he's going 60 miles an hour and the hill is 240, then it would take him 4 hours to get up. And then you say, but if he's going 40 miles an hour on the way down, it takes him 6 hours to get down. So then you can literally add together 204, 240 up plus 240 down is 480 divided by 6 plus 4, 10. 480 divided by 10, and you'll get 48. Like literally that example works. And then you could try a different hill size and it'll work. You'll always get 48 because the X's cancel out. So wait, I'm looking at the time. So we have like 10 minutes. I'm going to, in words, explain the next problem. I may not but you could still all redo anything if you want to for points, blah, blah, blah. But before I do the next problem for 9 minutes, let me just ask, can everybody just raise your electronic hand if you're cool with this now, whether or not you were cool before, just raise your electronic hand if you're good. Cool. Awesome. Okay. Awesome. And you can put your hands down. I'm going to ask one more obnoxious question. And of course, the reverse. I don't want to single anybody out, but if you're still unclear, it's okay. And also, if maybe you're thinking like John Jay students often do, if you're thinking, I'm actually still not totally okay, but it looks like a lot of other people are, and I don't want to be that person and Yaverbaum talks too much anyway, so I don't want to be the person that now slows him down with a big new question before we move on. You could just put in the direct chat. Honestly, you could put in the direct chat, I'm not totally okay, but I'll talk to you about it later. You can do that and you'll get points for that. I get it, but I would like to know. So if you're not okay, but you want to talk to me about it later, it's fine. You put in the direct chat or just text me later, whatever. But it seems like you, so I'm going to ask one more obnoxious question with 8 more minutes. Raise your hand if in any moment at all, any moment ever, from the moment you first looked at the problem until now, raise your hand if somehow your understanding of the problem increased ever. Like you were misunderstanding something at one point, and now you understand. Okay. Oh, that's a lot. Okay, great. Awesome. And that doesn't mean it's because of me. It might be because you worked something out. Great. Or it might be literally nothing I've said made any sense. The only part that ever made sense was what Annie said. That's fine too. That's why we're a class. But okay, if you increased your understanding of it in any way, that means we're all getting our money's worth somehow. So awesome. Okay. So now, and you can put your hands down. Thank you. Awesome. So now I'm going to move quickly to the last problem, problem 3. Now I'm not going to write it all. I'll be quick about this one, but so I'm not going to do the step method for this one, because we have 7 minutes. So the bottom, yeah, okay. So the bottom line for this one is, once again, we have to respect this piece of truth. Okay, so I'm just going to talk. So sorry. Okay, right. Okay, so I'm abbreviating because we only have 5 minutes. It's out 80 kilometers. It's back 80 kilometers. She goes out at a speed of 40 kilometers per day. She comes back at an unknown speed. We want her average speed for the whole thing to be 80 kilometers per day, right? So what do we do? Well, So it's the same question as before, just we're given different information and asked for different information, but it's the same, right? It's the same question from before, just in a different order. So my bottom line analysis is this. For the entire, if for the whole thing, in other words, for the entire thing, we want the average speed to be 80, and the entire distance for the entire thing is 160. Therefore, the time for the entire thing has to be 2. That's the one piece of knowledge I actually have. I'll say it again. We want our average speed for the whole round trip to be 80 kilometers per day. We know that the distance for the entire thing is 160 kilometers. So 160 divided by time equals 80. Multiply both sides by time and divide both sides by 80. So T has to equal not 2 hours, 2 days. I'm sorry, 2 days. So that's not an answer. That's a fact that I just figured out. T for the whole thing has to be 2 days. So what I'm going to do is just figure out, well, how many days did she use up going out there? And I'll just figure out whatever she has left over. That's how fast she has to go, right? So how much time did she use up? I'm saying she's got 2 days to do this whole thing, but on her way out, she's going 40 kilometers per day. The whole trip on the way out is 80 kilometers. So if I do the math, she's already taken up 2 days to go out. So she's used up her entire allotment that she has for the whole thing. So she has 0 time to get back. So, physically speaking, I think she would have to go at infinite. She would have to get back in no time at all to accomplish this mission. She would have to go at infinite speed. That means to me, she can't do it. That does not mean I can't do the problem. Like the answer is she'd have to go at infinite speeds. I don't think that's physically possible. But I think that is the answer to this physics problem. Like the answer to the physics problem is the physics can't be done, or the answer to the thing is this human being can't accomplish that. But that's, and if you have questions with that, please, you could still redo your homework, blah, blah, blah. But that's, I think it's the same logic as number 2. It just happens to be trickier because you're getting an answer that's impossible. Doesn't mean the question's impossible. It means there's only one answer, that answer. No other answer will work. Okay, but you've been very, very patient. You've been very smart. So you were not crazy. Sorry, right. Direct chat person, you were not crazy. You're totally right. And that's the moral of the story is just like with the other one. If you get a physics answer that's bizarre, that doesn't mean you're bizarre. Okay, right. Good job. See you next week, right? See you next week. Yes.
Bye, Professor.
Bye. Have a good.
Professor.
Thank
Have a
you.
nice day.
Thank you. Have a good. Thank you.
So